Starling forces. Its name suggests that it has forces, no, but in reality we term this as pressures because we know force divided by the total cross-sectional area equals to pressure, no. Therefore we term this Starling forces, but it should be a force but as pressures. Therefore the Starling forces, there are two types of pressures, not the forces, pressures: hydrostatic pressure and colloid oncotic or the colloid osmotic pressure. Both are correct. Hydrostatic pressure and colloid osmotic or colloid oncotic pressure. First of all, what is the hydrostatic pressure in Starling forces? Okay, I will explain it. Suppose this is a glass. This is a glass bottle. Okay, glass bottle filled with oxygen gas. This glass bottle is filled with oxygen gas. What happened in the oxygen? There are oxygen particles, no, oxygen particles. These oxygen particles clashes with the wall. These oxygen particles clashes with the wall. Due to the clashes with the wall, it create a force, no, because the particle clash with the wall and it create a force. When we divided this force by the total cross-sectional area of the glass, and we can have a pressure. Therefore, sum of all these forces divided by total cross-sectional area equals to pressure of what? Partial pressure of oxygen. This is the simple theory we used in chemistry or in physics also. This theory apply to this hydrostatic pressure. How? I will explain you. This is capillary and this is the blood, no. Within the capillary there are blood. Blood contains particles. Your red blood cells, your WBC and your platelet, all of them. These particles also clash with the wall. These particle also clashes with the wall. This particle clash with the wall and create a force. When we divided this force with the total cross-sectional area of the capillary, we can have a pressure, no? We can have a pressure. This pressure is your hydrostatic pressure. Very easy, simple. Hydrostatic pressure. This is hydrostatic pressure of the capillary. Because capillary hydrostatic pressure occur due to what? Due to the clash of these particles with the vessel wall, and it create hydrostatic pressure towards this, again towards the wall of the capillary. This is the hydrostatic pressure. Okay, this is the capillary, no, and this space is we termed as interstitium or intercellular fluid, no. Interstitium is also filled with interstitial fluid. This interstitial fluid also contains particles. This interstitial fluid also contains particles, no. Therefore, these particles also clashes with the wall. These particle also clashes with the wall. Therefore, it also creates another hydrostatic pressure. It is from interstitium to capillary. It creates another hydrostatic pressure. This hydrostatic pressure occur within the interstitial fluid and it is from interstitium to capillary. And capillary hydrostatic pressure, it is occur from capillary to interstitium. These are the two forces related to hydrostatic pressure. Now you know what is hydrostatic pressure. Hydrostatic pressure is the particles collapse with the wall and it creates a pressure, and this pressure is termed as hydrostatic pressure. Therefore, hydrostatic pressure we can divide it into two parts. First one is the capillary hydrostatic pressure and the second one is interstitial hydrostatic pressure. Okay, now let's move on to the colloid osmotic pressure or colloid oncotic pressure, my favorite one. Because osmotic, what is the meaning of this osmotic word? Okay, I will explain you. This is your albumin and one of my favorite plasma protein, because albumin is the main or the major protein in your blood, in your plasma actually. Okay, why albumin is so specific? It has lot of function, but there's a beautiful function in albumin because it can attract water because it is osmotically active. What is mean this osmotically active? Osmotically active means it can attract water. It can attract water. Your albumin can attract more water. So it has it can efficiently attract water. Therefore, albumin is one of the most osmotically active particle. Okay, how the colloid osmotic pressure is built by albumin? I will explain you. Suppose this is your albumin, okay? This is your capillary, and this is your albumin, and this is your albumin, okay? And this is your another albumin molecule. What happened here is within the filtration, there's a filtration no, from the capillary to interstitial fluid. The fluid is filtered, but albumin cannot be filtered. But the water molecules can be filtered. No, water molecules is filtered into interstitial fluid. But albumin, what does the albumin do is albumin attract these water molecules from the interstitial fluid. This is your interstitial fluid. Albumin attract the water molecules from the interstitial fluid. Then it creates an attractive force towards the capillary. Due to this albumin activity, osmotically active albumin's activity, it creates the attractive force from the interstitial fluid to capillary. This attractive force, we termed is that the colloid osmotic pressure or the colloid oncotic pressure. Why it is termed as osmotic or oncotic? Osmotic means this is occurred due to osmotic, no, osmotically active albumin. And why it is termed as colloid? Colloid is mainly the albumin. Therefore, this force is mainly created by your albumin molecules. Okay, this is colloid osmotic pressure. So it is occur in the capillary because the albumin present in the capillary. Therefore, this is capillary colloid oncotic pressure. And also, yes, we know there are two forces no, from capillary to interstitium, capillary hydrostatic pressure. From interstitium to capillary, hydrostatic pressure of the interstitium. Okay, due to the fulfillness, we also terms another colloid oncotic pressure in the interstitial fluid, but there's no any pressure because the pressure we already know that it is occur from this interstitial fluid to capillary. Therefore, there's no any pressure. But we add this another pressure due to the fulfillness. Okay, now let's move on to the final one. Okay, what are the pressures? First, in the blood, there is a hydrostatic pressure in the capillary. We termed this as capillary hydrostatic pressure. And in interstitium, there is another pressure, interstitial hydrostatic pressure. Okay, and on the colloid oncotic pressure, there is a force. We term this as colloid oncotic pressure of capillary. Colloid oncotic pressure of capillary. And there's another pressure, but I already said that there's no any pressure, but due to the fulfillness, we add another pressure, interstitial hydrostatic pressure. No, sorry, interstitial colloid oncotic pressure of the interstitium. Okay. Now I am going to add the values for these pressures. First, the hydrostatic pressure. Hydrostatic pressure, it is 37 millimeter of mercury in the arterial end. And in the arterial end, interstitial pressure is 1 millimeter of mercury. In the arterial end, colloid oncotic pressure of the capillary is 25 millimeter of mercury. And this pressure, you can term this as, you can tell this pressure is 0. Because I already said that there is no any pressure, but we add a pressure due to the fulfillness. There is two forces, there should be another forces, no? There should be another couple of forces. Therefore, this is 0 millimeter of mercury. And this is the basic of the Starlin forces. And there is an equation, we term this as the Starlin equation. And this total filtration is equal to, there is a constant Pc minus P if minus phi C minus phi if. And we have to add these values to these equation and find the final result. That is a very simple one. You already know how to solve this, but the main part is to understand the basic of the Starlin forces. These are the basic of the Starlin forces. Okay, finally I will remind you hydrostatic pressure. Why the hydrostatic pressure occur? Why? Because the particles collapsing or the particles clashes with the wall. That's how the hydrostatic pressure occur. And this is the colloid oncotic or the colloid osmotic pressure. How this osmotic pressure occur? Due to the presence of albumin. Albumin attract water molecules. That's what happened. Okay. Is there a force of phi if? No, there's no any force, but due to the fulfillness, we add another force. That's what happened. Okay. I hope you understand this principles and Starlin forces. Then okay, if you have any doubts or comment in the comment section, and also subscribe and like and support me. Your support is very much to me. Thank you.